Chapter 2 Linear Equations in One Variable. Introduction. In the earlier classes, you have come across several algebraic expressions and equations. Some examples of expressions we have so far worked with are, so these are the forms of algebraic expressions which consists of constants and variables. Here 5 is a constant, x is a variable. Some examples of equations are 5x equals 25, 2x minus 3 equals 9, and so on. So what is the difference between algebraic expression and equation? Expression is simply consisting of constant and variable and no sign of equality is there. So that is what differentiate algebraic expression from equations. You would remember that equations use equality sign. As we have here, equality sign. It is missing in expressions. Here it was missing. So this is the basic difference between algebraic expressions and equations. Of these given expressions, many have more than one variable. Well, if you see here, we have only one variable x. Whereas if you watch here, we have two variables, namely x and y. For example, 2xy plus 5 has two variables, namely x and y, and constants are 2 and 5. We, however, restrict to expressions with only one variable when we form equations, because you are in learning phase. In higher classes, you will be dealing with more variables. Moreover, the expressions we use to form equations are linear. So if you watch here, 2x minus 3, so it means 2x raised to power 1 minus 3. Similarly, we have here 6 into z raised to power 1. Nothing written over the power, simply means 1. So this means that the highest power of the variable appearing in the expression is 1. These are linear expressions. Why are they expressions? Now you have revised what we have learned in previous classes. They do not have equality sign. That is this sign, therefore they are expressions. They are expressions. These are not linear expressions. The following one, x squared plus 1 y plus y squared. Why? Because highest power of any variable in the given expression is greater than 1. Here it is 2. Well, if you watch this expression y plus y squared, although we have y with power 1, that is y raised to power 1, but we also have y raised to power squared. So we will not take this variable into consideration. We will take variable having highest power. So it is 2, therefore it is no more a linear expression. It is quadratic, which we will study in future classes. Again, here we had 1, z raised to power 1, z squared. We will not take this. We will take this because it has highest power. Since highest power of variable is greater than 1 in all these expressions, therefore they are not linear anymore. So here in this chapter, we will deal with equations with linear expressions. That is, the expressions having highest power of variable as 1. In one variable only. Also, we will consider only one variable. Such equations are known as linear equations in one variable. Simply, if you break it, linear equations, that means variable having single power, and we will consider only one variable because you are in learning phase. This is a new concept to you. Therefore, we will only restrict ourselves to linear equations in one variable. The simple equations which you studied in the earlier classes were all of this type. Let us briefly revise what we know. So here is the given expression or equation. What is it? Well, it is an equation because equality sign is there. Therefore, this makes it an equation. Therefore, it is an equation. However, if you just write 2x minus 3, it would be expression. So that is the only difference between an equation and an expression. Here we have a variable. That is, we have only one variable, therefore one variable only, namely x, and it has the highest power, understood as raised to power 1. Therefore, it is linear equation in one variable. And obviously, this is left hand side because if you face towards this equation as you are watching the screen, when you point your left hand, this points to this expression. Therefore, it is LHS or left hand side. And towards this side, you have your right hand, therefore it is right hand side. So this was just the revision of your previous classes. That is all defined in point A. Also, point B states that in an equation, the values of the expressions on the left hand side and RHS, that is right hand sides, are equal. This happens to be true only for certain values of variable. These values are the solution of the equation. So equality mainly defines whatever is written on left hand side is equal to right hand side. So here it simply means if x is taken as 5, so 5 to the 10 minus 3 would give you 7, will hold true only if value of x will be 5. So it is also called as the solution of the equation. That is, what value should a variable have in order to equate left hand side equal to right hand side. So if you take x as 1, so it would be 2 into 1 is 2 minus 3. That will give you -1, which will give us wrong answer, or equality will not hold in that case. So that would not be your solution for that equation. Therefore, left hand side must be equal to right hand side, and the value that makes so would be your solution of the equation. Same has been defined here. On the other hand, if you take x is 10, so the value of left hand side will become 10 into 2 is 20, minus 3, 17, which is not equal to 7 obviously. This is not equal to RHS, therefore the value of x equals to 10 is not the solution of this equation. The point C states that how are we going to find the solution of an equation? So we assume that two sides of the equation are balanced. So it is a beam balance. Here you put the weights and here you put the product. Only the balance would point in the center here. That is in between only and only if the weight here equals the weight of the product. So if we have 5 kg weight over here, so we must have 5 kg product here. So we will learn such steps in order to balance our equation. So the first example has been given, 2x minus 3 equal to 7. So in order to find the solution of our equation, our aim is to separate variables from constants. So on left hand side or on right hand side, we will only have the unknown variable, and whenever we do so, we must keep the equation balanced. So here are the steps. First, we should eliminate 3. How we can eliminate 3? If we add plus 3, because we had minus 3 here, doing so we must also add on the other side plus 3, else the equation will get unbalanced. It is very similar to this. If you are going to add 3 kg weight here, you must add 3 kg here as well. So the same has been done. Now what we can do is 3 will get cancelled out, and you would be left with 2x as it is. 7 plus 3 is 10. Now we are left only with 2x. So how can we get rid of this 2? If we divide by 2. So the same has been done here. But again, if you are dividing this weight by 2, you must divide here as well too. Then only our beam will be balanced. So doing so, 2 get cancelled out, and 2 5s are 10. So x equal to 5 is the required solution, because now you can also check it. If you put 5 here, so it would be 2 into 5 minus 3. Obviously this is in bracket because BODMAS rules follow here. That must be equal to 7. And 5 to the 10 minus 3 equals to, must be equal to 7. Yes, indeed it is, because 10 minus 3 is 7 equals 7. Therefore, x is the required solution for this equation. Now if we consider another example, 2y plus 9 equals to 4. So it is an equation. Why? Because equality sign is here and we are studying it in one variable only. And it is linear as well. One variable, here it is y raised to power 1, having highest degree as 1. And only one variable is y. Now when we first look at this, we just have to leave y on left hand side and eliminate other constants. So we would be left with y with some equality here. Whatever will be on right hand side will be our solution. The one way is as we did here, that is we could write 2y plus 9 and introduce -9 so that this can be eliminated. So it would be 4. Again, we should introduce -9 in order to balance our equation. So this would cancel out and we would be left with 2y equals to 4 minus 9. But that was okay in previous classes. So if you observe what is happening here, this plus 9 is getting transposed. Well, this is the basic concept which ultimately leads us to this step, that is transposing. So by practice we learned that it is a simple step. If we just shift this 9 on right hand side, the only thing is we have to change the sign corresponding to that value. So here it was plus 9, we would take minus 9 when it is shifted towards right hand side. Basically, actually we are doing this thing. So rather than repeating this thing again and again, because it consumes a time and effort to write, we simply transpose. Whereas we again tell you that the basic step is this one only. So we did this step. Now how we could eliminate y? So next step is simple. We must get rid of this 2. This could be done by dividing both sides with 2. Why both sides? Because we have to keep the balance. So here we divided with 2. Again here with 2. So this 2 got cancelled and we are left with only y on left hand side. This becomes minus 5 over 2 and it is the solution. While it is a good practice to check the answer while you are in learning phase. So we will consider this 2. It is getting multiplied with our solution because we are checking it right now. Minus 5 over 2. Minus 5 over 2. Bracket closes. What is here? Plus 9. And we have to check whether it comes 4. If it comes 4 after solving, our solution is correct. So 2 cancels out. Minus 5 plus 9 is 4. Therefore, it is a required solution. So do you notice that the solution minus 5 over 2 is a rational number? Well, it is a rational number because in the form of p by q where denominator is not equal to 0. In class 7th, the equations we solved did not have such solutions. It were integers or natural numbers. So what we infer from this, that our solution may also be rational numbers. Now let's see example 3. So this is the equation. It is in the form of rational number. So we will not subtract on both sides here. We have learned our new method, that is transposing, which basically means the same thing. So if we will shift this 5 over towards right hand side, here it is having its head as plus, or the sign with it is positive. So we are going to subtract it here when we take it to right hand side. So x equals to 3 is left on left hand side. This is our left hand side. And this as it is, so we wrote minus 3 over 2 as it is, plus becomes negative 5 over 2. So you don't need to take LCM because denominator are same, to straight away use this. Minus 3 minus 5. Same sign, add up and sign comes of negative. 5 plus 3 is 8. We are not finished yet. So we are left with x equal to 3 on left hand side and on right hand side minus 8 over 2. Also if you simplify it, 2 1s are 2, 2 4s are 8. So basically we are left with minus 4 on right hand side, or the same thing has been written left hand side as it is, x equals to minus 4 here. Now we have to get rid of this 3. So we could multiply both sides with 3. So if we introduce 3 here in multiplication, we have to do same here as well into 3. So this 3 get cancelled out and we are left with x equals minus 4 into 3. And when you solve it, it is x equals to minus 12. But again, if we check it, we will write in place of x as minus 12, the same has been written, divided by 3, rest as it is. So when you solve it, it is 3 4s are 12, therefore minus 4 and plus 5 by 2 as it is. This is understood. Denominator as 1. So LCM is 2, 1 2s are 2, 4 2s are 8, obviously of negative sign, plus 2 1s are 2, and 1 5s are 5. Solve it, you get minus 3 over 2, which is equal to our right hand side. Now it says, do you now see that the coefficient of a variable? So what is the coefficient of a variable? Whatever constants we are having with a variable, our coefficient of that variable. So here we have x over 3. So the coefficient of x in this case is 1 over 3. Or take an example as 5x over 6. The coefficient of variable x here would be 5/6 because it is getting multiplied with it. So it need not to be integer as it used to be in our previous classes. So the coefficient of a variable can also be a rational number. Now we will see the last example. So we have 15/4 minus 7x equals 9. So we have to leave x only on left hand side. So we see 15/4, a rational number which is having a plus sign. We will transpose it to right hand side. It will become minus 15/4. So the same has been done in this step. So minus 7x as it is, 9 minus 15/4. This as it is, solve it. This was understood. Divide it with 1. LCM is 4. 1 4s are 4. 9 4s are 36. Minus 15 gives you 21. So this step has to be done in rough. And we got 21/4. Now minus 7 is getting multiplied with our variable x here. We have to get rid of it. This could be achieved if we transpose it to right hand side. Here it was getting multiplied. Here it will get divided up. That is multiplied in division. It is actually dividing minus 7. It would be very similar writing as this, dividing both sides with minus 7. The same thing. So it get cancelled out. We are left with x equals 21/4 into minus 7. Solve it. 7 3s are 21. So 3/-4 or minus 3/4, you know very well this negative sign can hover to any of the three positions which you have learned in previous exercises. Now we could check, you know very well how to check. After learning this, we will solve our exercise.